Have you ever wondered how grounding is done hundreds of miles above Earth? On the ground, it is simple. We connect a wire, a rod, or a metal plate to the Earth. Extra electricity flows safely away. But now, imagine a spacecraft in orbit. It is moving at high speed. It is surrounded by vacuum and plasma. There is no ground. There is no soil. Nothing to connect a wire to. So how is grounding done in space? To understand the answer, we first need to understand why spacecraft become electrically charged. Now, we are not just listing effects. We're looking deep inside every layer of spacecraft charging. Because not all charging mechanisms are equally dangerous. Some are slow, some are violent. First, let's talk about the Earth itself. Our planet is a giant magnet with magnetic field lines stretching from pole to pole. Now take the ISS, a massive metal structure over 100 meters long, and hurl it through those magnetic fields at 17,500 miles per hour. Basic physics tells us that when a conductor cuts through a magnetic field, it creates a voltage. This is exactly how a generator works. Because the ISS is so big and moving so fast, this Lorentz force pushes electrons to one side of the station. This creates a permanent voltage gradient across the hall. The station isn't just carrying electricity, it is generating it just by moving. The second reason is even more aggressive. The ISS uses massive solar arrays that output 160 volts of DC power. But here's the problem. These arrays act like a giant electrical brush scrubbing through the ionosphere. The space around the station is filled with plasma, a soup of loose electrons. Because the station's negative power line is bolted to its metal skin, those solar arrays act like a giant electrical vacuum cleaner sucking in electrons from the surrounding space. Before we dive into NASA's master plan to fix this, if you enjoy these deep dives into space mysteries and high-tech engineering, please hit that subscribe button and turn on notifications. Now, back to the solution. In 1991, NASA formed an electrical grounding tiger team to tackle this crisis. That is when they created the Plasma Contactor Unit, or the PCU. These units are located on the Z1 truss, the central backbone of the station. This isn't just a metal box, it is a ground-to-space bridge. But how does it actually work? Inside the unit is a hollow cathode. The system leaks a tiny amount of xenon gas, which is then hit with electricity to create a glowing plasma cloud. This cloud creates a physical electrical path between the station's metal frame and the vacuum of space. The excess electrons trapped on the station flow through this plasma bridge, latch onto the xenon ions, and are safely discharged into the void. But the big question is, why xenon? Why not use a cheaper gas? There are three main reasons. First, it's inert. It doesn't react with the station's sensitive parts or cause corrosion. Second, it has a low ionization potential, meaning it turns into plasma very easily with very little power. And third, it has a high atomic mass. This makes the discharge process incredibly efficient and stable. Space may be a vacuum, but it is not silent. There is an invisible electrical war happening every single second. The transition from the simple wires of the Apollo era to these plasma shields on the ISS shows just how genius human engineering has to be. We aren't just running a station, we are fighting the laws of physics to maintain a safe island at 0 volts. So, do you think we will use these same plasma shields when we eventually land on Mars? Let me know your thoughts in the comments. I'll see you in the next video for another deep dive. Until then, stay curious.